says that if the fraction of the atom of a radioactive material left after 120 years is 1 by 64, what is the half-life of the material? So here are the options. As usual, we're going to solve and see which option corresponds with our answer. Solution. If you recall, n is equal to n naught into 0.5 to the power of n, where our n stands for the number of possible lifetime given by t over t half. And don't forget that you can write 0.5 as 1 by 2. So if we divide both sides by n naught, you're going to have n by n naught to be equal to 1 over 2 to the power of, instead of n, I'm going to use t over t half. There's another way you can go by this question. You may decide to solve for n before you find your half-life, but I'm going to solve the half-life directly. So our n by n naught in the question is given as 1 over 64, that is the fraction. 1 by 64 equal to 1 over 2 to the power of our t, the time is 120 years, 120 years divided by half life. So we can re-express this as 1 over 2 to the power of 6, which simply means 1 over 2 all to the power of 6, because 1 power 6 is still 1, which is equal to 1 over 2 to the power of 1 over 20 all over half life. We now see that the base are equal. We are going to equate the power according to law of indices. So we see 6 equal to 120 divided by half-life, which simply means that our half-life is equal to 120 divided by 6. And this should give us 20 years, which corresponds with option A. So that is that for the half-life.